All right, I have Frankie here, and we are going to teach you about position versus time graphs. So let's take a look at this. So, what is a position versus time graph? Here's one right here on the left. Um, Position is on the horizontal position is on the vertical axis. Thanks, Frankie. Is on the vertical axis, and that's measured in meters. Time is on the horizontal axis, and that's measured in seconds. So, what does this do? This tells us about the motion of an object. The object we're going to use is Frankie. And the mistake students make is they think, okay, so Frankie's going to move up, across, and down. That's not really how these things work. What we need is that horizontal line that tells Frankie's horizontal position. You can see that if I place Frankie here, he's at a position of -2 meters. And that makes sense because if we look at the graph at time 0 seconds, so there at the origin, Frankie is at -2 meters. So let's let time pass and see what Frankie does. 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4. At 4 seconds, Frankie is now here at +2 meters. And that makes sense because if we look at our position versus time graph, we can see that as time passes, 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4, Frankie is at +2 meters. And so that's how it maps onto the motion, which is pretty cool. So what does he do next? He sticks around for 2 more seconds. 0 Mississippi, 2 Mississippi. He stays at that 2 meter position. And then at 6 seconds, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi, he makes his way to position of 0 meters. So it would look sort of like this. 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10. So he's moved to the left in this case. And that makes sense. If we look at our graph, we can see that this line has a negative slope, and that's going to be important later. So why do physicists like these so much? Well, they tell us about the object's velocity. And I bet you can figure out how pretty quick. Take a look at these two lines here. We have green monkey and purple snake. Off the top of your head, who do you think is moving faster? Which one has a greater velocity? Green monkey is a faster velocity because the slope is greater or steeper. That's a steeper slope. And guess what? The velocity is the slope. The velocity is the slope of the line. So let's find Frankie's velocity. Let's find his speed by looking at the slope. And let's look at this first 4 seconds. Let's look at that part of Frankie's motion. So in order to find slope, I like to think about rise of a graph divided by the run. So I draw a little triangle just like this. Just like that. So how big is the rise, this part of the graph? Well, it's 4 high. It's 4 meters high. And how long is the run, this part of the graph? Well, it's 4 seconds. And so we end up getting this formula here. The change in position, or the rise of the graph, is 4 meters, and the change in time is 4 seconds. And so we end up getting 1 meters per second. 4 divided by 4 is 1. And look at, we even see the units for velocity show up. And that's how we can calculate the speed of an object. So, can you calculate the speed of this object? You have the slope, or you have the line shown here. Can you find the slope and therefore find how fast it's going? Good. All right, the last thing that I want to show you guys is a graph that has a curved slope. So if we have a curved slope like this, the velocity is actually changing. So let's think about this top graph here. Let's call this graph A. Let's look at how the slope is changing over time. So here we have a pretty shallow or flat slope. But later in time, we have a really steep slope. So the slope is actually getting steeper. It's getting greater. It's a higher number. It's a greater magnitude. This tells, and if, remember, slope is velocity on a position versus time graph. And if that's true, then the slope is the velocity. So I'm going to put a little v here for velocity. And the slope got steeper, so I'm going to do a larger v. Now tell me, is this object speeding up or slowing down? I'll let you think about this one. And I'll actually have you think about this graph here, graph B as well, and try to answer some questions about it. And that's all for now. Thanks, Frankie. You did great.